Okay, today we're going to be talking about lesson 12. The objective today is students will multiply a decimal fraction by single-digit whole numbers, including using estimation to confirm the placement of the decimal point. We're still not using that standard algorithm, and I know it's a little frustrating to the parents, but we're getting there. We just want the students to have a good strategy than just one strategy, which is a standard algorithm, which is a step-by-step procedure, and they miss one step and they get the whole question wrong. Our essential question for this lesson is, how can I use estimation to confirm that my product is reasonable when using multiplication? A lot of times, even in real life, by using estimation, we can get a reasonable answer. And we're going to use this a lot in order to verify our exact answers. All right, so let's try to put this into practice. Now, this says choose the reasonable product for each expression. Notice it says expression because it doesn't have an answer. An algebraic equation would have 4 and 2 7 times 6 equals and some answer. So when it says an expression, it just means it doesn't have an answer. So let's see. If we're using, it says explain your thinking in the space below using words, pictures, or numbers. Well, I know from what we've done in the past that if I was going to round to get an estimate, I'd take 4 and 5, and we know this is 4 and 5/10. And I'm writing around to the nearest whole number right here. So I know 4 and 2/10 would be about here, so I'm going to round to 4. So now I got 4 times 6 equals 24. So now I know that 4 times 27/100, or 4 and 27/100 times 6 is approximately 24. So if I look up at the possible answers up here, I know my answer has to be close to 24. If I look here, this is 2,562. This is 256 and 2/10. Now I have 25 and 62 hundredths. That's only 1 and 62 hundredths away. So this here looks pretty good right now. And the next one's 2 and 562 thousandths. That's no way. So by using our estimation, we were able to pick out the answer that was closest by knowing where that decimal place was. Let's try this again on D this time. This time it says 9 times 4 and 82 hundredths. Once again, if I do my rounding line, I want to go to the nearest ones place, so I know it's between 4 and 5. And I know right between 4 and 5 is 4 and 5/10. I have 4 and 8/10, so I know 4 and 8/10 is going to be here. And anything on the middle and up is going to round to 5. So now I know that 9 times 5 equals 45. So I know that 9 times 4 and 82 hundredths has to be approximately 45. Now, once again, I'm looking for an answer up here that's close to 45. Well, 4 and 338 thousandths is not close. 43 and 38 hundredths is very close. 433 and 8/10 is not close. 4,338 is not close. So since we know the decimal place would be approximated here, we know that this is our most reasonable answer. Okay, and our last question is a word problem. Let's try to apply this to a word problem. It says Ying Ting weighs 8 and 3/10 kilograms. Her older brother is 4 times as heavy as Ying Ting. How much does her older brother weigh in kilograms? Well, I like using tape diagrams to make sense of the problem. And I know that we're looking for Ying-Ting weight. And we know that, how about that? They're both named Ying-Ting. How about that? So we know that we'll call him Ying-Ting number 1. Okay, and we're listed as number 2. We know that he weighs 8 3/10 of a kilogram. Now it says that the Ying-Ting number 2 up here we're calling him weighs 4 times as much. So I know that if I take 8 3/10 kilograms and extend it out 4 times, that should be how much he weighs. All right. So now to write this down, we know if we had 4 times 8 3 kilograms. Well, if we rounded this, we know that it would be 4 times, let's round it, find out where it goes. We know it's between 8 and 9 kilograms. Right in the center is 8 5/10 kilograms. 8 and 3 would be here, so it's going to be closer to 8. So we know he's got to be close to 32 kilograms. Now let's see how that helped us. Okay. Well, if I just did away with the decimal point, and let's see, I added 83 times, 4. Well, 4 times 3 is 12. We're carrying our 1. 4 times 8 is 32. And 1 is 33. Well, I know it's got to be close to 32 kilograms, so my decimal point must have to go right here. So the answer would be that Ying-Ting weighs 33 2 kilograms.